with your answer here in just a minute. Okay, take 1 minute and consider those questions. What do you think? Is water a mineral?
No.
Oh, hush. Peyton. Is water a mineral? Why not? Go through the list. Is it naturally occurring? Oh, so now you know. Okay, thank you, Tanner. All right, so yeah, water's not a mineral because it's not solid. It violates the, has to be solid. So then let me ask you another question, Peyton. This time without Tanner's help. So is ice a mineral? Water's not a mineral, it's ice. Why? This is something you have to ask. Okay, go through the list. Is ice naturally occurring? Yes. Is it inorganic?
Yes.
Does ice come from living things? No, so yes, it's inorganic. Is it a solid? Yeah. Does it have a specific goal or a specific chemical composition? Yeah, what's that chemical composition? What's water? Well, what's the chemical composition of water? Okay. And does ice have a definite crystalline structure? Yeah, you guys ever watch Snowflake form? Okay. Really, really big. Very crystalline in shape. So yeah. So this is yes. Well, water is no.
Ice is only a mineral if it's not like in the freezer. If it's like
All right. So yeah. So like we have over here on the side, right? We have the copper sulfate that was a mineral when we put it in, right? It was definitely a crystalline structure. And as soon as we put it in the solution, it started to dissolve. So right now, it's no longer a crystal, or no longer a mineral. Okay, so what I want to do now, the rest of the class, we're looking at these 5 categories, looking more at what they actually mean. So again, what does it mean to be naturally occurring? Has to happen in nature.
yeah.
And inorganic?
Not
Not from living things. Does anybody know what amber is? Well, what is it? Amber.
Is it like a yeah, it's a rock, but is it like a different yeah.
Yeah, it definitely has a golden hue to it.
Is it like the color of brown?
Yeah, it's in between gold and brown. Yellow, golden, brown.
Yeah.
Okay, so okay, go. If we saw, we might know what it is. It's basically a tree sap. It's fossilized tree sap. Sometimes it bugs. So is amber a mineral? Yeah. Yes.
But how does it get like
That's where the mineralogist actually will shape it.
yeah,
Which
so
is-
it's
well, it is not a mineral, not because it comes in the shape of a sphere. That's usually what has been finalized. But it's because it's from trees. It's actually an organic substance. And so therefore it's not inorganic, so therefore it cannot be a mineral. So solids with specific compositions. Again, each mineral has its own unique chemical composition. Oftentimes we get minerals that are composed of a single element. Kind of like Tanner, he wants gold, silver, copper, iron. Okay, those are composed of single elements. Lucky for you guys, I have a little bit of copper to pass around. I do not have gold. No. But when we look at minerals, most of them are going to be made from compounds, specifically silicates. Remember we talking about SiO4. Where'd my silicate atom go? What's over here? It's falling apart. Well, I did have a silicate atom. I should have one more little ball at the top. Okay? And basically we get this little tetrahedron. Kind of looks like a pyramid. And that's going to be your silica. We'll talk about that later on in this lesson. We look at crystalline structures. This one will have a lot to pass around on here. The crystalline structure is because of the atoms themselves. And this is where I think sometimes we underestimate or really just don't appreciate what's really happening in the world around us when we look at something. When we look at the minerals, we look at all their different shapes. The shapes of the crystals is completely because of an interaction that's going on at the atomic level. And so what we see on this macro scale as this crystal is actually because of the way that the atoms are aligning themselves relative to one another. And it's actually that geometric pattern that determines the stability of the mineral itself, whether it's a fragile mineral or a very hard mineral. So when we think about diamond, diamond is a very, very hard substance. That basically is the highest hardness level, and nothing can scratch diamond. And that's all because of the crystalline structure of diamond.
So how is it cut?
Well, the diamonds are cut. It can't be necessarily scratched. Basically, it's cut with all the diamonds. Okay, so it's a very, very difficult process to do that. And then we have 1 of 6 types we're going to talk about today. And you don't need to be a master artist, but I do want you guys to kind of write down at least the names and try your best to kind of sketch them. The first one is cubic. Cubic. Actually, exactly what it sounds like. It's a cube. Okay. Common types of cubic structures is fluorite. Coming out right now is a purple sample of fluorite. And I have another green sample of fluorite. This is one that if you put up to the light, you'll see the 3 colors in the crystals. That's another piece of fluorite. Tetragonal, basically if it looks like a shoebox. Hexagonal. Now again, guys, that's a rough estimate. Hexagon usually meaning 6 sides. Okay. So actually I have 2 samples here. The red sample is called aragonite. You'll notice that most of your minerals end in an ITE or an INE. So aragonite. This is actually kind of a cluster of aragonite, also known as a rosette. And then, in this case, what you're actually looking at here, this is called pink tourmaline. Pink tourmaline. I actually have black tourmaline here that I'm passing around, and you actually will see how the tourmaline, if you guys look at the sample really closely, you'll see that the black rod actually forming inside the quartz crystal.
Where did you get all these rocks?
I go to rock shows. Yeah, hit or miss. Depends on what you consider expensive.
Is that apple one on the top row like made?
Yes. Guys, quiet down. tetragonal.
Yeah.
Basically, it means like a box, shoebox.
I know
Okay.
what we're on.
I don't know.
What it means.
Orthorhombic. Orthorhombic. Basically, the orthorhombic, you can kind of see this rhombus shape right here. Kind of have this slanted. If you guys take geometry, you understand what I mean by orthorhombic. And if you look at the silver in here, which is called sphalerite, 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 you'll see this orthorhombic crystalline structure there. Also, this big rock coming around is a little bit of pyrite, which actually pyrite is cubic. So an example of this would be sphalerite. Now, we talked about earlier the monoclinic versus triclinic. Think about clinic as coming to a point. And then mono, bi, tri, and quad. Think about those as the number of faces it takes to get to the point. So mono means how many? One. So what you have is a single face that comes up to the point. So that's monoclinic. Triclinic, you can see right here, this is an example of triclinic where we have three faces coming together to the point. Okay, an example of that would be quartz. Okay, so your quartz crystals typically are triclinic. Okay, so those are your 6 types of geometric crystal structures.